You click a button on a website and a page loads, but what mechanically happens inside the web server during the 50 milliseconds in between? Most people treat a web server like a black box. A request goes in and HTML comes out. If we open the box, we don't find magic. We find a highly organized, high-speed industrial assembly line. This maps the architecture of an IIS server. Notice the horizontal split. The bottom half is kernel mode. The top is user mode. Kernel mode sits deep in the operating system, interfacing directly with the external network for speed and security. Above it, user mode connects to backend databases. This is where your memory-intensive application code executes. If your server hardware fails or the operating system panics, the crash happens down in kernel mode. If your code gets stuck waiting on a slow database query, the hang happens up in user mode. Knowing where a request lives in this stack tells you exactly where to troubleshoot. When an HTTP request arrives, it lands in kernel mode at HTTP.sys. It checks its cache. If pre-computed, it loops the packet back to the network. If dynamic, it sends it upward into user mode, entering the worker process called w3wp.exe. This worker process is the engine that actually runs your application. If it is asleep to save memory, a component called the Windows Process Activation Service, or WAS, wakes it up to receive the incoming packet. HTTP.sys acts as a high-speed toll booth, handling the fast, simple tasks deep in the OS. The heavier, resource-intensive worker process is only spun up when the server truly needs to construct a custom response. Once inside the W3WP worker process, the request enters the managed pipeline. This is a sequence of discrete modular checkpoints. First up are authentication and authorization. These modules inspect the incoming packet to confirm the user's identity and then verify they have the correct permission levels to access the resource. Before the request is handed off to the actual application code, it has to clear one more critical module to ensure the server knows exactly which piece of code to execute. It's the routing module. Once the packet clears this routing phase, it drops into the central application code core. Your code takes over, queries the database, and constructs the final response. But the journey isn't over. This response travels in reverse along the same pipeline, passing modules that compress output, gets logged at log request, and drops to http.sys to exit. The server pipeline operates as a two-way street. The outbound journey handles your server analytics, error logging, and bandwidth optimization, making it just as critical as the inbound business logic. Let's put this architecture to the test. Imagine an unauthenticated user attempts to access a highly secure admin dashboard. This red packet enters http.sys. Uncached, it moves up to the user mode's authentication module. It detects missing credentials and hits a hard barrier. Assigned a 401 unauthorized status, the packet routes straight back down, completely bypassing the application code. By rejecting the bad traffic at the very first gate, the server protects the application logic. It saves massive amounts of CPU cycles and memory that would have otherwise been wasted processing an invalid request. This visual summarizes the mental model you need for IIS. 1. HTTP.sys catches the request in kernel mode. 2. It passes it to the W3WP worker process. 3. It navigates the managed pipeline from authentication to the application code. And 4. The finished response makes the return trip. Memorize this flow, and you will always know exactly where your web requests are living and where they are failing.